The finale of the finale, the Great Bubble Barrier.
Hi all, thanks for your attention. I think you've seen this logo already a couple of times in the presentations before, and now I finally can tell you what we're doing. We're the Great Bubble Barrier, and we're facing a challenge with all of you. The world is slowly polluting with plastic, and this waste in all the rivers and in the oceans is killing lives over there. So we set a goal, and we set a goal to find a solution which is an elegant solution, a solution that can be applied everywhere on all kinds of rivers. And for the sailors and biologists, it should be fish and ship friendly as well. And with this solution, we wanted to catch all the waste in every streaming waters in the Netherlands and maybe beyond that. We came up with an idea of a jacuzzi. And the idea is based on a tube on the bottom of a river with small holes on top of it in which air is pumped through. This will create a big curtain of bubbles, and it will block all the waste going downstream to the ocean. Moreover, it creates an upward thrust to make sure that not only the plastic that is on the surface of rivers, but also the plastic that is underneath and in sublayers of the river is being blocked and being pushed to the surface. Now that was a good idea, and then we thought it can be even better. If we put it like this, so you see the two beams of air, the little bubbles, diagonal on the river, we can use the current of rivers to make sure that the waste is not only blocked, but also streams to the side of the river where it can be caught by, for example, a conveyor belt, or plastic safe, or any other solution you can put there. To keep it simple, we made a schedule with a conveyor belt in it, but you can come with other solutions there as well. But it has several benefits. As I said, it's already fish and ship friendly. The fish appeared to be not really afraid of this kind of bubble curtains, but we still wanted to make it easy for them to pass through. So it's a little slalom, as we call it in Dutch, a pass. All kind of ships and big traffic and small ships can just pass over it without being affected. It's a total solution that catches all kind of waste on the width and depth of every river. It doesn't need a lot of maintenance, actually it's really, really low, and it's multi-applicable, what I already said. And it has one other advantage, aeration over there. It makes sure that because of the oxygen, it increases the oxygen levels in this kind of streaming waters. And that is really beneficial for all kind of ecosystems. It's a proven technology. We already have a couple of suppliers that can apply this kind of technology, but it's a new concept. People are not using it for waste yet. They're using it in the oil industry, they're using it to separate salt from fresh water, and even to block noise, for example. Here you see a bubble barrier that is used to block oil. I don't know if everyone can see it. And we're talking with these suppliers already. We made our own model to test if it also blocks waste. You see underwater, plastic is being caught, and it's being pushed to the corner over there. And then if you see above the water, it slowly goes into the corner over there on the surface and is being caught by the conveyor belt. So we thought this is the perfect solution for our problem. It's economical, you can implement it in the existing infrastructure, and it also gives a huge image boost next to catching only plastic, because you can do with everything with the design. We would like to start to implement it together with governmental institutions, such as water boards and municipalities. And later we would like to go to private sector to also make sure that the little rivers and the more smaller canals can be blocked by waste streams. And it's an inclusive concept. For example, for events, we can make it visually attractive with lights. We already have developed an interactive education plan to make sure that awareness is increasing. And because we're researchers, we like to collect data to improve the research on this topic. We still have some questions left, though. So we would like to do a pilot to find out how this kind of system is working in a dynamic structure, such as the ISO, for example. Then we can find out which is the perfect bubble size, how the impact is of the current of that river, what kind of pressure is needed, and we can specify our energy requirements. Although we think if this kind of curtains can divide salt from freshwater, why wouldn't it separate microplastics from other kind of butter, which is bigger in size? So we would like to propose two kind of pilots. One in October, within a couple of months, at 10 meters in a natural way. And then next summer, a full operating system to find out the questions I've mentioned before. So we need a pilot site, of course. We need construction and hydraulic engineers. We need funding to do those kind of pilots. And we'd like to have a startup coach to help us to make this as economical and smooth as possible. We've already been talking to a lot of suppliers and partners, and we would really like to co-create this idea. And I would like you to invite to come up with, talk to us, and make this one big solution. Thank you for your attention.